We're now doing 5.4 trig functions. Copy this down. In order to find the acute angles of a right triangle, you use the inverse trig functions. Say that again. In order to find the acute angles of a right triangle, you use the inverse trig functions. So, what information are they going to give you, and what information are you going to have to find? Correct. They're going to tell you that this side here is 8 and this side here is 10, and they're going to ask you to find either A or B or both. Okay, and you have to kind of go backwards and use the inverse trig functions in order to find A and B. Well, what are the inverse trig functions? Well, instead of sine, which is the normal trig function, we put a little -1 there, and that means inverse sine. Same thing with cosine, same thing with tangent. If you look on your calculator, above sine, cosine, and tangent, in blue are inverse sine, inverse cosine, and inverse tangent. I understand this looks like raised to the -1, but we read it as inverse sine, inverse cosine, and inverse tangent.
So you don't have to have like when you do like sine A, would you put sine to the negative first and then an? You know what I mean?
Yes, along those lines. I'm going to show you the example right here in just a second. So Corey was exactly right when he said they're going to give you some sides and ask you to find the angles. When you're finding angles, you have to use inverse. That's kind of the key phrase. If you're finding angles, which is unlike what we did yesterday and this morning, then you have to use inverse. Okay? So if this is our example, and we'll just erase and we'll say we're talking about x down here. I just want to simplify. We're talking about one variable down here, this angle. If we're trying to find x and we're given an 8 and a 10, which trig function can we use? Tangent. Why? Because we weren't given a hypotenuse. Right? Sine and cosine deal with hypotenuse. Tangent deals with opposite and adjacent. So everybody would agree that the tan of x equals 8 over 10. Right? The regular tangent of that angle, x, is some ratio equal to 8 over 10. Okay? In this scenario. In order to go backwards one step and find the angle, x, we use the inverse tangent of 8 over 10, and that equals x. In order to find the angle, we do the inverse tangent of the opposite over the adjacent, and we end up with x. Everybody practice on your calculator.
Would you simplify that?
Great question. Alan asked if we would simplify the 8 over 10 prior to typing it in your calculator. You do not have to. Your calculator is smart enough to know that you don't have to simplify. Right? 8 over 10 is the same as 4/5, but you don't have to simplify. Great question. All right, so you type it in on your calculator, and what do you get? X is rounded like money. 38.66. All right. So if x is, this is the best part about this problem. Leave it on your calculator. Don't hit clear. This is the best part. If x equals 38.66, instantly, how can we find y if they were to ask you for both angles? We just hit minus 90. It's going to give us a negative number, but we're smart enough to know that this angle is what? It's not negative. It's going to be a positive number. We're doing it out of order, and that's why we get a negative number. So we simply subtract 90 from this value, and we get y is equal to the complement, to use a geometry term, is what? 51.34. Are these numbers always going to add up to 90?
No.
Yes. 99% of the time they're going to add up to 90. Sometimes when you round funny, they don't. But most of the time they're going to add up to 90. Because you rounded, they might not. But most of the time they're going to add up to 90.
That was a negative.
Correct. All right, everybody asked. She asked, 51 was negative. Well, an angle can't be negative, not in Euclidean geometry. So we just leave it as positive 51. Positive 51. Questions? Okay, so let's recap. They're going to give you two sides and ask you for an angle. We're going to set it up right here with a regular tangent of x, or unknown angle, is equal to the ratio opposite over adjacent. Then we set up the inverse tan like this, and we solve that on our calculator. I don't have any problems if you don't even write this down. You don't even have to write this down. Okay, if you can figure out that it's going to be the inverse tan of 8 over 10, you don't have to write anything down. Your calculator will do it for you. Okay, it's that simple. Round like money, or whatever the directions say, and you're done. Questions? Yes?
How do we tell if it needs to be regular sine or regular tan?
Okay, how do we understand if it's going to be a regular trig function or inverse trig function? And the answer is, if we're looking for angles, then we use what?
Inverse.
Inverse trig. Okay, good question. Anybody else? Correct?
So when you have it tan x equals 8 over 10, you just switch 8 over 10 to x.
Yes.
Is that every time?
Yes, every time. Because you're doing the inverse of that ratio, then it's going to go backwards and it's going to tell you the angle measure. Okay? That's the beauty of the inverse trig function.
Are we going to like run into it where we've got to find the angle before finding the side?
No, because they wouldn't ever give you that. They might tell you that side and that side, but they have to give you at least two sides. They have to give you at least two sides. Okay? All right, let's look at one more example. Okay? Sometimes they may just ask you for one angle. They may not ask you for both. But in this case, we're doing both just because we can. Okay?
No.
Okay? So, if I'm going to look at angle A first, I'm just picking A because it comes first. If I'm looking at angle A first, what is the relation of the 6 and what is the relationship of the 14?
Adjacent over hypotenuse.
This is adjacent and this is hypotenuse. So which trig function are we going to use? So I'm going to say the cosine of what? No. The cosine of A, whatever that angle is, equals 6 over 14. That's what we did yesterday. That's what we did at the beginning of the period. But now, because we're going backwards and we're finding A, well, how are we going to set it up? The inverse cosine of what? 6 over 14. That's a 6. 6 over 14 is equal to what? Somebody tell me on my calculator. It equals X, you're right. And then what is it at rounded like money? Say it again.
64.62.
Thank you. 64.62. Okay, questions? Then if I instantly want to find B, all I have to do is subtract 90. When it's all written out there, I'm not rounding or doing anything first. I subtract 90, and what do I get for, not A?
25.38.
And then what would be, say it again?
25.38.
25.38.
What did you just do?
I had an X there, and I didn't mean for it. I
No,
meant for
but
it
no,
to be.
what did you just do with the subtract?
I said minus 90 to get the other angle. These two angles here are complementary. They have to add up to 90. So if I take that value and subtract 90, I'll get negative 25, but I know it's not negative, right? The
So you
angles
could
have
add
to.
them and then
You
subtract
could,
180 and get that.
but the only problem with that is you would have to either round or you'd have to do it all over again. You see what I'm saying? Now we don't round, it's simply minus 90 equals, and we get the answer. We just have to be smart enough to know that it's not negative. Okay, questions? All right, good. And let's